When OSPF calculates the SPF, shortest path first, it uses a metric called cost. The cost reflects the speed of a link between two routers. Here are the cost values. Fast Ethernet or faster is a cost of 1. Ethernet a cost of 10. An E1 line, that's a European type of line, is a cost of 48. A T1 line is a cost of 64, and the old 128 kilobits per second was the old phone modem speed, and that's 781. So how is this calculated? Well, it's calculated by 10 to the 8th divided by the speed in bits per second. You might see a problem here. Fast Ethernet and faster are all a cost of 1. So gig Ethernet, 10 gig Ethernet, these are all still a cost of 1. This system was designed before we had gig and 10 gig Ethernet systems. So let's take a look at the calculation here. This is Fast Ethernet. Fast Ethernet is 100 megabits per second. That's 100 million bits per second. Well, that's also 10 to the 8th power. So if we take 10 to the 8th power and divide by that 100 million bits per second, we get 1. Now what happens if we have gig Ethernet? Well, that's a billion bits per second. So we end up getting 0.1 for the solution. Well, you can't go below 1, and so it's rounded up to 1. So you can see why all of these gig and 10 gig are all still 1. So what can we do about it? Well, we have the power to change the metric. For example, if I change the metric to 10 to the 9th power, now I have 1 billion here and Fast Ethernet at 100 million, and that gives me a cost of 10. If I have 1 billion here and 1 billion for gigabit Ethernet, now I have a cost of 1. Of course, I could keep on going. I could make this 10 to the 10, and that way I can account for 10 gig Ethernets. 10 gig would then be a cost of 1, and 1 gig would be a cost of 10, and Fast Ethernet would be a cost of 100. So that's how we can get around this problem.